All right, so let me start. Does anybody have any questions? Anything from yesterday? It was easy, it was good. All right. All right then. So let's begin.
So this is on C.
Let's see.
Will be for letter B and C. For problem C.
Okay.
Number three.
Read it to me.
18x y squared z.
Wait, hold on. My pen now not responding real quick.
Okay.
All right, 18. Uh-huh.
18x y squared z. That's number three is C. That's letter B.
Mm,
Fourth degree binomial.
yeah, yeah. That's it? All right, that's right. Anybody else? Or we good? Yeah.
The E negative 24 by itself is a 0 degree binomial.
Correct. Yeah.
Thank you.
Okay. You're welcome. No problem. Yeah. So yeah, so let's get my screen good. All right. So yeah, we're gonna do a little mock exam tomorrow. Just come in. I'm gonna give it to y'all. I'm gonna try and give it to y'all at 9. All right. Reason being is that I want to be able to grade it so that you guys can get it back and know what you need to practice, right? And then if you need to, I'll tell you like, all right, you need to practice this packet or something, right? This topic from this day, whatever. You know, rewatch the video, look at do the packet, like to build up your skill set for Thursday, and then you're good. That's how we're gonna move forward from there. Right. Tomorrow I'm gonna give you guys a review sheet as well. Not a packet, it's not as dense, but it still has a lot of questions on it. And that's gonna be more geared towards the actual test on Thursday. Like the questions on that review sheet are gonna more look like the ones that you're gonna get on Thursday. All right. All right. I said I was gonna do something else also, right? Hey, how are you? Um, what was I gonna ask y'all? Today's Tuesday, right? All right. So you know what? Before I even jump into anything, right? Just bear with me 1 second. You know how you know you're getting old though, man? Like, you know how you know you're getting old though? Like when they come in and take a test, they don't even like make the mistake on you. They just like, you know. All right. Cell phones, computers, take them out. All right.
So you need like a new.
Yeah, take out your computer, take out your cell phone, whatever. All right. Huh? No, no, no. I'm gonna show them something. So I'm gonna hook y'all up. That's what I'm gonna do right here. So long story short, BCC has a lot of resources, right? I'm about to show you guys one of the resources that we have on campus, right? So on Google, this is what you're gonna type in. You're gonna type in BCC, the word and, ARC for ARC, intake form, right? First link right there where it says ARC intake form. You're gonna click that. All right. It's gonna take you to this page. Did everybody get that so far? You can do it too, Fabricio. All right. So we're Googling BCC, the word and, ARC, ARC intake form. All right, we're good? Everybody got that? All right. This blackened box right here where it says ARC intake form, you're gonna click that. All right. Now it's gonna take you to a Microsoft Forms page, all right? You're gonna click right here where it says start now, and you're gonna fill that out. All right. Let me tell you about what this is. On campus, we have a resource center called the ARC Resource Center. In this center, this is where you can get basically help with any needs that you might have outside of school, right? Some things that come to mind, if you need like psychological counseling, they got that for free. If you need like help with some type of judicial affair kind of thing outside of campus, they got that as well. If you have some issues with housing, they do that as well. The main reason why I want y'all to fill this out today, right now, as a matter of fact, right? Every 2 weeks, our school has a pantry, right? What pantry is a place where you go and you get free groceries. Tomorrow is grocery day, all right? But you need an appointment to get it. You have to have this thing filled out to get it. This is free, doesn't cost you a dime. You just come in with bags, they give you groceries, all right? I'm saying groceries, I'm not saying hot food. So I'm talking about things like eggs, bread, milk, right? Canned foods, right? Vegetables, fruits, right? Like groceries, like not like a cooked meal. I'm not talking about that, right? However, again, today if you go to Low Hall on the fourth floor, there is hot food, all right? So go ahead.
Over there yesterday.
Yeah.
You get mushroom, chicken, pasta.
Right? See?
Seafood, pasta.
That's good. Yeah. So they got that. They also have a little snack cart that has like fruits and drinks on there as well that y'all can take advantage of. So this is the same people. The same people that I'm sending you guys to every day to get the hot food. These same people, they have a pantry and they're giving out groceries tomorrow, right? No, they're not cheap. So I'm not talking about like come there with like one little bag and that's it. I'm talking about like in some cases you might need to push a cart. You might need to push a cart, especially if you have like a family of like five or something. You definitely need a cart, right? They're not cheap. They even give out meat there and stuff. I didn't even say that, but they give out meat there too, right? Chicken, turkey, all kind of things, right? Don't even get me started on Thanksgiving. Yo, y'all have no idea about Thanksgiving. Thanksgiving passed yet? Can't remember. It's coming up, right? Yo, Thanksgiving is crazy over there. Crazy. Like straight up. Just letting y'all know. All right. They even got stuff in there that has nothing to do with pantry. I'm talking about like toothpaste, toilet paper, right? For no reason at all. Y'all got newborn babies. They got what's that thing called Infamil or whatever? The formula. Yeah, they got all of that. All right. Take advantage. Take advantage. All right. So click start now. Fill that out. This is the summer right now. This is summer. Yeah, yeah, yeah. Summer 2025. All right. Yeah.
I ain't gonna lie, got pretty fast with it. Nah, but I'm
Yeah.
like the both did.
Yeah, yeah,
And
yeah.
I didn't forget that they just made a new thing to sign in.
Yeah. If you want though, like I'll tell you what you could do. You can go to Roscoe Brown.
Yeah.
They could fix all the logins, right? Yeah, yeah,
Now, I always used to get it.
yeah.
I couldn't get it. They used to make change like every semester.
Every 6 months. Yeah, 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 yeah.
Then now I got an NFA factor.
That nonsense.
I
Yeah.
didn't do it yet. Now
You didn't do that yet? You gotta go do that, man. Like that's really important, man. Yeah.
I'm gonna do it.
So if I sent you an email, you weren't even gonna get it because you can't check your
No,
email.
no, I can give you my, it still doesn't check email. I can still check my email. In my
Okay,
Outlook.
okay, okay.
But I need to write space,
Got you.
no reworks, nothing.
Yo, we need that. You can, that means you can't even register for classes next semester.
No, I registered. Fine.
Okay, okay.
Yeah, I'm right.
I got you. All right, so yeah,
I'll do this
Roscoe Brown do that.
Thursday or Friday.
But listen, if I told you that pantry day is tomorrow, you ain't got no time, right? Today when you go for lunch, right? You ask them to sign you up for pantry. All y'all got your Ample IDs and stuff. So y'all they can do that, they can do that manually for you. Right? Yeah. So
Actually, talking about that, but
yeah.
yeah,
I know you go to work after, so it's a little yeah. I got you, I got you. Yeah, yeah, yeah. They do help you get food stamps. Yes. Yeah, yeah. Nah. Over here, they got special people that help you to do it. If you need food stamps, they'll help you with that too. All right. Yeah. 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 Now, if you want to, like when you fill out this form, right? This is a comprehensive form of all of the resources that they provide, right? I'm having y'all filling it out so right now so y'all can get groceries tomorrow. But that doesn't mean that like what you call it, you can't take advantage of any of the other resources that they provide right now, you know? For me, I actually fill this out, right? This is where I do my taxes for free every year, you know? Keyword there is I said I. They don't do it for you. But they do help you. All right. So that's that. That's my spiel for today. Don't say I ain't hook y'all up. Everybody that's absent, they got it on video. All right. Let me get back to our regularly scheduled programming. All right. Y'all know before the movie, you always got to start off with a commercial, right? Yeah. Yeah. All right, let's look at what we getting into today. Oh yeah, Mary, you could fill that out too. Yeah. For huh? They do. Yeah. They all diet types. They have all of that. Yeah. Veggie burger, veggie patties, yeah, they have produce here. So they have like some of the stuff is frozen, some of it is canned, some of it is fresh, you know. Um Here's a caveat though, right? So for us that works, we can't go until the end of the day. So we can't go to the end of the last day, right? So during the semester, that's Thursdays, right? The end of the day, Thursday. All right. But right now for the summer, it's only doing Wednesday, so it's the end of like after work. After work, yeah. Like they could go at lunchtime and then we just go at when we leave, huh? No, bi-weekly, twice a week, yeah. So yeah, so if tomorrow is the day, that means that not next week, the week after next. Yeah. So just yeah, you seen them. That's where they coming from. Yeah. That's where they coming from. They coming from pantry. No, yeah. 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 I got you. Yeah. Yeah. I got you. But yeah, so just to let y'all know, so if pantry is tomorrow, That means that the next one is 2 weeks from now. So it's bi-weekly, every 2 weeks. All right. So that's like what? Is that the week that we come back to school? Yeah. So the week we come back to school will be the first day for pantry. All right. How you doing, man? You here for the calculus review? Messing with. Nah, I miss you, man. Haven't seen you in a minute. Maybe during the lunch break, somebody hook him up, let him know about the pantry stuff and all that I told y'all. All right. So let's begin. Help me out with this. I know my timetables is not that good. We distributing, right? So,
First, we have the
uh-huh. These are like old packets. If anything you need, if you need scrap paper, pencil, pen, go ahead. So we're gonna distribute, right? So help me out.
it's gonna be 2 times x, 2x,
This was yesterday's, by the way. That one is day before.
but equals
Uh-huh. So this is 2x, right?
2x plus 3.
Plus 6, right? Because 2 times 3, yeah. And then that's it. Any questions on this? We good? All right, let's keep it moving. Let's keep moving. Let's keep moving. After this, we're gonna have another commercial break. I just realized there's something I should have showed y'all that I didn't. All right. Oh my God. Good luck. Help me out. I'm doing a rainbow on this one because this one hard.
Said,
What's A?
5,
Yep.
9 times 9, 81.
All right, so A is 81. All right.
81.
Good. B. Very good. How about C? No. Negative 81. All right.
This thing that's out.
All right, so let's run through it. So A, right?
9.
Yeah, 9 squared, we know is just 9 times 9, right? B now, right? This is negative 9 squared. What is that? That's negative 9 times negative 9, right? But C, right? This is negative 9 squared. What is that? That's negative 1 times 9 times 9, right? Parentheses matter, right? That's the difference between all of them. All right.
Negative 1 times.
Mm-hmm. That's what the negative sign on the outside without the parentheses means. But when it's inside, it gets carried with the 9, you know? That's the difference.
So the 9 is positive, is negative, the 1 is negative.
Yeah, yeah. The minus sign in front of the 9, that's the negative one. Yeah. All right. Last one before our commercial. Oh Lord, how are we gonna do this? It's going. All right. So I have what? 2
2 times 6 squared
times.
negative
Very good. Minus. Uh-huh.
5 times.
Wait, hold on. Okay, we good. And then good. Any questions on this step so far? All right. I'm just plugging in the value. That's all I'm doing. All right. Everybody good with this? All right, just do the math on that then, right? Exponent first. This is what? 2 times 4 minus 5 times negative 2 plus 3, right? Let's do the math on that. 2 times 4, what's that? 8. Help me out with the middle.
Positive plus 10.
Plus 10, very good.
Plus 3.
Plus 3, all right? And we're just going to do this. This is going to be 18 plus 3. Let's call that, what, 21? All right. Questions on this? Anybody? We good? Know how to plug in numbers? All right, let's look at what we're getting into today. We actually got a lot to do today. I'm not going to lie. All right. So we're going to be multiplying monomials. That's what we're starting off with, right? So we are ready to perform operations on polynomials. Since monomials are algebraic expressions, we can use the properties of exponents to multiply monomials. All right, let's get it. It's going to be easy. All right. Well, no, it's gonna be hard. I ain't gonna lie. No, let me stop lying to you. It's gonna be hard. It's gonna be hard. All right. Because we gotta know our timetables, like I still count my fingers and everything. So y'all don't see me doing it, but I'll be up here doing it, All right. Hey, I got 3x squared times a negative 4x cubed. All right. Let me give y'all the most simplest advice ever, right? Numbers with numbers, variables with variables. All right. Numbers with numbers, variables with variables. Help me out. What's 3 times negative 4? All right, negative 12. Good, good, good. And then what's x squared times x cubed?
X.
X to the 5th power. Very good. Right? So remember that whenever we multiply the variables, we add the exponents, right? And then 3 times negative 4, we know how to do that. Any questions on this? Anybody? Don't be shy. Now's the time to ask the questions. We got a test on Thursday. All right. Let's look at B. So what do I have? I have 5 over 6 x cubed y times 12xy squared. Oh, baby. How we do this? All right. So help me out with that. What's 5 over 6 times 12?
Well,
Okay, let's do that. It's what? 60?
60 over 6.
Okay, you want to do it like that? I wouldn't do it like that, but okay. And then 60 over 6 becomes 10, right? All right. Now, I'm not as good as math as you guys are, so this is how I would have done it, right? I got 5 over 6 times 12 over 1. 6 goes into 6 once. 6 goes into 12 two times. 5 times 2, 10. That's how I do it, right? But I have to do things like that because I don't know my timetables, right? I'm just faking it till I can make it, you know? All right. So now, what I got? I got 10. Help me out. I have x cubed times x. What's that?
X to the 4th power.
Good. Keep going.
Then we got y. Y times.
Very good. This is my final answer right here. Any questions on this? Anybody? Good. Well,
Y that final time.
it is.
Y that final looks at the top. Usually get 20 plus like this.
Good. I got you. Yeah. 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 Got you. You took 0.5 before or regular? Got you. Got you. All right. Commercial break. That's the.
Can I ask you a question? But the minus sign is outside the parentheses, and then inside the parentheses, another minus sign. Will you distribute the negative sign just to the minus sign or to everything in the parentheses?
So whatever's in the parentheses, that's what's getting copied. And then that minus sign on the outside gets applied to the final answer. Yeah.
No, plus sign.
Yeah.
We don't need-
All right, bear with me 1 second. Da-da. All right. Once again, I'm still waiting on emails and all of that, right? So until I get that, let me just show you guys in class how to get to the page at least. So I'm assuming everybody knows how to get to YouTube here. All right. All right. So this is what you're gonna type in right here, the search bar. You're gonna type in BCC and what's the name of this program?
Workshop, asking workshop.
Summer Bridge,
Bridge.
right? Summer Bridge, right there. All right. I don't know what all that other stuff is. This is us right here. BCC Math 28.5 Summer Bridge. All right. If you go there, there's a whole playlist. All right. There's a whole playlist that you guys can go to find it. Let me see if I get to where the playlist is. Playlist right here. Good, beautiful playlist. This is everything. Day 1, day 2, day 3, day 4, day 5, day 6. Well, day 6 is pending, right? But yeah, so everything is there. All right. Like, subscribe, set 6. Please say 6 here. Like, subscribe, share with each other, whatever. Y'all know the drill. All right. If you're unsure what the video is about, there's a description under the video, right? I'm gonna just click on the first one. That's here. Pause it because I'm not really trying to watch it. But you have a little description right here. It tells you about what's gonna be in the video. All right. Y'all can read through, you know, all that good stuff. Right. All right. Let's close that out. That slows down the computer. And let's get back to our regularly scheduled program. Doo, doo, doo. All right. So yeah, you guys know how to access it now. I apologize for the wait. I thought I had your emails sooner, but I didn't get that. Um, real quick, this was our last problem. How you guys feel? Do y'all understand it or do y'all want to see another one? Understand it? Everybody good? Good? All right, let's keep it moving though. So here's what we're getting into now. All right. We're gonna multiply a polynomial by a monomial. So multiplying a polynomial by a monomial is really just applying the distributive property, all right? Just like how we did in the example. Nice and simple, all right? So here we go. So I have a negative 2y times 4y squared plus 3y minus 5. And I have a 3x cubed y times x squared minus 8xy plus y squared, right? So here's what we're going to do. We're going to distribute this to every single term. Just keep it simple, right? Numbers with numbers, variables with variables, all right? Negative 2 times 4, what's that? All right, so I heard negative 8. All right. Y times y squared is y cubed. Very good. All right. Negative 2 times 3. What's that? Negative 6. All right. Good, good, good. And y times y is what? Y squared. Good, good, good. All right. This is going to be a hard one. What's negative 2y times negative 5? Positive 10y. All right. We good. That's it. That's the answer. Any questions on this? Anybody? Y'all good? All right. Not good? You good? All right. All right, we're gonna do crimson now, right? So I got a 3x cubed y times x squared. Tell me what to write. This is B.
Wow.
Good. All right, let's try it again. I got a 3x cubed y times negative 8xy. Negative 24. Hold on, I gotta think about that. Yeah, you're right. You know, I don't know my timetables. I got it. All right. You said x to the what? Uh-huh. Y what? Y what? Y squared. Okay, there we go. There we go. There we go. All right, last one.
3x to the third and 5 5.
Good. That's my answer. Any questions on this? Anybody? Good. All right. Low-key, that's like the whole topic for the day. Mhm. But I got more practice coming. Do y'all want to see another one or y'all feel good? Good. Another one? All right. All right, try this out. So remember, what we want to do here, you want to distribute, right? Numbers with numbers, variables with variables. All right.
Not gonna lie, this put you in one week. I know
That's what I'm saying.
you get it up to the top of that.
We right here right now. That's what I'm saying. That's what I was saying. Yeah, man. Nah. If this was the semester, it'd have been like 5 more weeks before we hit radicals. Yeah.
That's what I'm saying, right? Because at the end, so I need to know it, but I don't fail. I don't know.
Yeah.
As long as I know my polynomial,
Yeah.
I can run. And I know you do polynomial.
Yeah.
That's that fine.
So like I was saying, this test that we taking Thursday, right? It's all plus side for you, right?
The workshop about that thing. A lot. There's a guy in the workshop. I've got a thing up on polynomial.
Yeah. But here's the thing, right? If you guys pass this test on Thursday, y'all all get to go into 28. That's a blessing, right? If y'all don't pass the test, y'all gonna go into 28.5, right? But you guys are going with all the videos that I just showed y'all, all the packets I just gave, right? Y'all gonna be chilling for the next 5 weeks, you know? Yeah, for real, for real.
What's been 5 weeks?
No. It's like 12, it's like 15 weeks. It's like 15 weeks. But the point is that like I don't hook y'all up with like the first month of information already. You know? When the semester starts, always tutoring is not open the first week. Tutoring always opens the second week of the semester. But y'all already have the work for like the first month, you know? So all y'all have to do, like after class, just go to tutoring, do the homework. You know, just do the homework and tutoring. Real nice and simple. You don't have to have a question to come to tutoring. Just go there and do homework. You know? And then after that, test is coming up. Y'all have a practice test that y'all already will have done. It's gonna be the same idea, right? Y'all just like what's up?
Told me you supposed to go really follow me.
You should have,
You
man.
said that on the paper. I didn't.
Yeah.
That's why I think. Yeah.
Yeah.
I knew it was one month. I knew it was possible.
So you got an incomplete.
Yeah, so I got to get my final 18 also. They said, but I don't have to stop being prior appeal, my professor. But you know, legally that's the deal. But then I think if I'm smart enough, I can take this to 18, which I probably should. If I fail, I still got another chance.
Mm.
I ain't gonna take 18. But if I take the 18, I pass.
Okay.
Whoever passes on the 18th incomplete is in the list because we get to pass before
Okay.
26.
Got you.
Whoever got the incomplete.
Got
It
you.
was more than me. When I went to the workshop in first.
Cause you was on that day that they closed school down.
Huh?
Like I don't know if you remember, like there was a huge storm.
Yeah, that's what I did that day.
Yeah.
So she said,
Yeah.
or something like that.
Yeah.
Doctor. He was like, we had a mandatory come to the July workshop. Then when I came, there was nobody there, and then he said, "Look, you can't make it."
Yeah.
I still popped up.
I got
Then
you.
on the day of the final, the split up.
It was a storm.
It wasn't too crazy. The governor just
Yeah.
closed the school to make it look good.
Yeah.
She stood state of emergency. It wasn't too crazy. Oh, back then it was. Flooded. The train station got flooded.
Yeah. Yo, Instagram was going crazy with that joint, yo. Yo. Yeah.
Like you waist deep in that water.
Yo, you saw when they was playing the floor is lava?
Yeah, but that ain't my job. I'm saying you saw them waist deep in the train water? Nah. Never. You basically in that water that you see in the train, bottom, you just swimming in that.
But this be making me mad though, man. Then they want to raise the fare, and we over here like every time it rains, we swimming to get home. You know? Yeah, and a little rain too. It's not even like crazy rain. But wait. Our whole lifetime, we ain't never had that before.
Wasn't like this back.
Right. That's what I'm saying. You know, like so I don't know what changed. You know? I don't know.
The earth is melting.
That's weird. Yeah. I heard that they have this thing. Starts with a B. I don't actually remember the name of it, right? But long story short, when you flush things down your toilet, right? Like especially things they're not supposed to be flushing down the toilet, right? Like they like come together and they make like a glob or something, and that glob like grows in the sewer system kind of thing, right? So I don't know if we have a whole bunch of globs that's like that needs to be like filled like fixed or something, you know?
When you see him, the major league, the state trooper came in big boots and he was kicking the things. Yeah, it's locked up, but it's great. Let me tell you something. They only go to Seymour. Who the sites are good? The big Seymour, you see it?
I didn't see that. I didn't know that they had that.
The big one, man. Jacob Reese Park, not Jacob Reese Park. I think it's Jacob Reese Park across from Jacob Reese House, but that's a different name. They built the park. The park is 20 feet above the sea level.
Wow.
You ever see
I didn't even know about that. Yeah.
You gotta see it. Yeah. That's only in rich neighborhood. Everybody else be not.
Yeah. No. I mean, we not a rich neighborhood, but we straight.
Over here.
Yeah, we straight.
I think this is the tallest point of the phone, right?
It is, yeah. Like no lie. I'm not talking about that day that the governor closed school, but a couple weeks before that, we was getting some crazy rain, right? And I remember seeing it on Instagram and all that. I was here teaching, right? And then, but when I look out the window, it's like it's just drizzle. It's nothing. But then when I go home and I look on Instagram, it's like, oh, like, yeah, yeah, yeah. All right, let's take a look at this real quick. Hey, how you doing? So first thing I want to do, let's distribute this. All right, help me out. What am I going to write? So I heard negative 15 y cubed. Very good. All right, then I have a negative 3y times a positive 8y. What's that? Good. And then I heard a plus 21 y. Good, good, good. Now we're talking. Good, good, good. All right. All right. Questions on this? Good. All right, let's flip in and reverse it. All right, boom. So for B, all right. Why you not working? Okay, there we go. So I have a 4x squared y squared times 3x squared. What's that gonna be? X4 y squared. Good. Next one. Good. Last one. Y what? Good. Any questions on this? Anybody? Good? You got them all? Hmm. Hmm. Yeah. Then I'm gonna print the packet and be like, boom. Yeah. 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 Tomorrow is our review day. Today is like brand new material, just going through the motions, all of that. All right, this next topic, I'm pretty sure everybody in here knows how to do. All right. So we're gonna be multiplying a binomial by a binomial, right? So just like there are different ways to represent multiplication of numbers, there are several methods that can be used to multiply a binomial times a binomial. We'll start by using the distributive property. This is my favorite one, by the way, right? Yeah. We could talk for hours. All right. Distributive property, right? I'm gonna do the easy one and y'all can do the hard one. Hey, what's up, man? So I have y plus 5 times y plus 8, right? So here's how we're gonna do it. Starting off with the y plus 5. I have y. I'm gonna distribute the y plus 8 to it. So this is gonna become what? Y plus 8. And then I'm gonna distribute the y plus 8 to the 5. It's gonna become what? Hold on. Plus 5 times y plus 8. After that, you already know what's gonna happen, right? Distribute this, pop, pop. Distribute this, pop, pop, and that's it. Excuse me. Sorry about that. Yeah, lots of people. So now what do I have? Oh. All right, so we have y squared plus 8y plus 5y plus what's 8 times 5 again? 40. Appreciate y'all. After that, you want to combine like terms, right? It's a fancy way of adding. So this is going to be y squared plus 13y plus 40, right? And that's it. Questions on this? I need some water. What? Mm-hmm. Because I have to multiply them together, right? So what I'm doing is I'm distributing it to each one, each term, and then I distribute again, right? This is my favorite method. Yeah. Questions on it though?
We call this method,
Distributive property.
that's different from Euler's method.
Yeah. I like this one more. You know? Mhm. Yeah. It is the same thing, kind of. You know? Five was given. Yeah, so it was given, so that's why I put it there. So basically, you break up the first term, right? And then you just distribute the second term to it. Try B for me. Tell me what's right. It can be. That's another method. I'm gonna go over that too. Go over that too. Let's try B real quick.
Use that distributive method.
Mm-hmm. Tell me what's right. Hmm? What? I got you. Well, it's this building. That's what that is, man. Yeah.
Well, why you said, I don't know how to do it.
4y times what?
What times 2y minus 5.
Very good. All right. And then what else?
3
Plus 3.
5.
All right. Times 2y minus 5. Right? I'm sorry. 1 second. Let me just move this. All right. After that, just distribute it right out. Boom, boom. 4y times 2y is 8y squared, right? And then 4y times negative 5 is negative 20y. Good. And then 3 times 2y is plus 6y. Good, good. And then 3 times negative 5 is what's that? Negative 15, right? And then you want to combine like terms, right? So it's a fancy way of saying add, right? So what's the answer? I have 8y squared. Hmm? Hmm? I'm distributing the 2y minus 5 to both terms. It's a distribution. Right, to the 3 and the 4y. That's why it's twice there. In the middle now, I have negative 20y plus 6y. What is that? Negative 14y. Good. Minus 15. And that's it. That's my answer. Questions on this? We good? Y'all need another one or we can move on? What do we say? Move on? We don't need another example. Everybody's good? All right, let's keep it moving then. All right. So if you multiply binomials often enough, you may notice a pattern, right? Notice that the first term is notice that the first term in the result is the product of the first terms in each binomial. The second and third terms are the product of multiplying the two outer terms and then the two inner terms, right? And the last term results by multiplying the two last terms together. All right. So we all know that pattern right there. Y'all know where I'm going with this, right? So we abbreviate the terms first, outer, inner, last as FOIL, right? So the letter stands for first, outer, inner, last. We use this as another method for multiplying binomials. The word FOIL is easy to remember and ensures that we find all four products. Let's multiply x plus 3 times x plus 7 using both methods, right? Distributive method, right? I want to distribute the x plus 7 to every term over here, right? I want to distribute that x plus 7. So I have x times x plus 7, and I have 3 times x plus 7. After that, distribute it back. Bop, 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 bop. And then that's how I get the x squared plus 7x plus 3x plus 21. Combining like terms, I come out with x squared plus 10x plus 21. Or we could use the FOIL method, first, outer, inner, last. So our first term is going to be like this, right? So that's going to be x times x, that's the x squared, right? Our next term will be the x times the 7, right? Which will give us the 7x. After that, we're going to have the inner terms. We're going to have the 3x times x. That's going to give us a 3x. And lastly, we're going to have the 3 times the 7, which is going to give me the positive 21. Combining like terms, we come out with the same answer, x squared plus 10x plus 21. Right? So we summarize the steps of the FOIL method below. The FOIL method only applies to multiplying binomials, not other polynomials, right? This is why I like the distributive property more, because that method works for every single thing. But FOIL only works for a binomial times a binomial. All right? That's the secret. For those of you just seeing FOIL for the first time, I got y'all. All right? So here we go. This is how to use the FOIL method to multiply two binomials. First, you multiply the first terms, right? The first term. So that would be like the A and the C right here, right? Step two, you multiply the outer terms, right? So that's going to be the first term, the A times the D, right? Step three, we're going to multiply the inner terms, right? So that's going to be the B times the C, right? Step four, we're going to multiply the last terms, right? So that's going to be the B times the D, right? After that, you just combine like terms and boom, you're done. All right? Questions on this? We good? All right. Got a little itch in my eye. 1 second. So when you multiply by the FOIL method, drawing the lines will help your brain focus on the pattern and make it easier to apply, right? Now we will do an example where we use the FOIL pattern to multiply two binomials. All right. So go ahead, y'all do that real quick. I got something I need to do on my end, so knock that out, right? Just fire. Yeah, this is what I actually learned in high school. I didn't learn the distributive property till here. We should run around and check that everybody understands. We're doing on foil right now. These are old packets. You're just multiplying to binomials.
Well, you know about that. Everything they think. Amen, judge. Eventually. But if you don't. Oh, yeah, that's something they get complete. They don't drop. So she's saying she would have dropped it last, people like to drop it, like, fail, you know,
Hey, how are you?
You said you were doing something. And by the way, found you on YouTube and you never uploaded.
I did it. I'm doing it right now.
Man,
Nah, this thing takes a long time to download. It just finished right now. So that's why I'm trying to do it
But I
right
saw
now.
other stuff that you have put up.
Yeah. That's all every day from day one up to yesterday. No, up to
I
Thursday.
think you said 50 or something.
Yeah, yeah.
Question for you. I noticed you yesterday that you do tutoring out of here or whatever. Do you think, because I know today you're gonna let us know
All right, y'all. That's gonna take a little while, but it'll get done. All right. So what I was doing is the video for yesterday. I was trying to push that to YouTube right now. It's gonna take a little while. It'll eventually get there. Y'all have it before like the end of class or something. All right. Today's video, y'all have it tonight. All right. Like, I hope so. All right, let's look at A real quick, right? So for A, what did I get? I got y squared minus 3y minus what's that? 7 7's 14, 28. Everybody got that?
Yes, sir.
Awesome. You're probably looking at like, yo, how you do that in your head? Yeah, there is a trick to do it in your head. I'm not gonna lie. But we'll talk about that another time. All right, so we have what? 8x squared, right? Then we have, oh shoot, 20 plus what's that? Negative 14x minus 15. Everybody got that? Awesome. All right. Let's keep moving. I'm not even gonna ask y'all which way y'all did it. I'm happy with whatever way y'all did it. All right. Bop, bop, bop. All right. Let's keep it moving. So the final products in the last example were trinomials because we could combine the two middle terms. This is not always the case. All right. So check this out. All right. So let's look at A, for example, right? I have n squared plus 4 times n minus 1. However you want to do it, you want to FOIL it, you want to do the distributive property, your choice. I'm choosing to do the distributive property, so I'm going to distribute n minus 1 times n squared. So I have an n squared times n minus 1, right? Then I'm going to do a n minus 1 times 4, so I'm going to have a plus 4 times n minus 1. I'm going to distribute this back. So now I have what? N cubed minus n squared. I'm going to distribute this plus 4n and then distribute that. 4 times -1, -4. And that's it. All four of these terms are different. They cannot be combined. Trying here. I'm trying to draw straight. We try it. There we go. All four of these terms are different. They cannot be combined. So that's the final answer. And that's it. All right. Try out B for me. I mean, tell me what to write when I say try it. Nobody? All right. Let's do the FOIL method, right?
So you wanna do it out loud?
Yeah.
3 PQ times 6 PQ,
Which is
18 P squared, Q squared.
18p squared q squared. Good. All right.
Then 3 PQ times -11,
Which is
-33 PQ.
good. All right. Enter.
Then it's 5 times 6 PQ,
All right. So what's 5 times 6?
30.
So plus 30 PQ. I ran out of space. That's why I'm doing it like this. All right. Last.
You got 5 times -11.
Which is what?
5.
-55. Good. All right. Let me move this box real quick. All right. After that, what do we want to do? Combine like terms, right? What do I have?
You got the 18 P squared,
Uh-huh.
Q squared,
Good.
minus 88, minus 33 PQ.
Uh-huh.
But you can't add
Minus what?
you can't you can't do exactly that. You see how you got it on top of each other?
You can do that.
So we only.
I ran out of space, that's why I did that.
Yeah, we only have negative 3PQ.
Uh-huh.
Take out that 33.
Uh-huh.
Minus 55.
55. I'm sorry, what were you gonna say? What were you gonna say? Oh, I got it, got you. All right. All right. So that's it. How you guys feel about this? Let me just check something. Yeah, that actually worked out. How disappointing. All right, whatever. How you guys feel about this? Yeah, I wanted it to be 4 terms like the first one, but yeah. Yeah. That's what I'm looking at. I'm like, yo, this is so disappointing, but it is what it is. All right. So how you guys feel? Y'all, huh? Yeah. Do y'all want to see another one or y'all feel good about this? What y'all think? Move on? Move on? All right. Y'all get the idea. So that last one was a mistake. But let's talk about that mistake, right? Since you're asking about it. All right. So the FOIL method is usually the quickest method for multiplying two binomials, but it only works for binomials. You can use the distributive property to find a product of any two polynomials. Another method that works for all polynomials is the vertical method. All right. It is very much like the method we use to multiply whole numbers. Look carefully at this example. Yeah, look carefully at this example of multiplying two digit numbers, right? This right here is the reason why I don't know my timetables. Keep it 100 with you, right? When they was trying to teach me 1 through 12, I was like, all right, I'm gonna memorize this. And then when we got to 13, I'm like, what do we do? And they showed me this method. I'm like, y'all gotta memorize Jack. I can always figure it out. All right. So boom, y'all remember how to multiply two-digit numbers? All right, we go through this. 6 times 3 is 18. Put the 8, 1 up right here. 6 times 2, 12 plus 1, that's a 13. Boom. Right? Then we got to put imaginary 0. Then we got 4 times 3, 12. Put the 2, 1 up. 4 times 2, 8 plus 1, that's the 9, right? Then you want to add these together. I don't know why we've got the plus sign. We want to add these together. Adding straight down, 8 plus 0, 0. 3 plus 2, 5. 1 plus 9, 10. 1058. Right? We all remember how to do this. Basic multiplication, right? So we're gonna actually do the same method using the polynomials. All right. It's the vertical method. It's what you was asking about a second ago, man. All right, so check this out. Check this out. Check this out. So here go the question right here. So I got 3y minus 1 times 2y minus 6. I'm about to do the vertical method on this, right? So what does that look like? It's going to be like this. I have 3y minus 1 times the 2y minus 6. The parentheses just make me feel good. That's why I'm doing that. All right. So step by step, -6 times -1. What's that? +6. All right. -6 times 3y. What's that? So -18y. Right? Boom. All right. Imaginary 0. 2y times -1. What's that? 2y times -1. What's that? -2y. All right. Put a plus right here. Now, last one. 2y times 3y. What's that? So +6y what? Squared. Very good. Very good. Very good. And you already know the next step, right? I'm going to add these together. Add straight down. 6 plus 0 is -18y times -2y is adding. Negative 18y plus, no, negative 18y plus negative 2y, negative 20y. Supposed to be a plus here. And then 6y squared, just bring that down. That's it. That's my answer. That's the vertical method. Same method that you learned from when you were younger. All right. Now, I will never tell you what method to do on a question. All right. Y'all do whatever is most appealing to you, right? You want to do the distributive property like how I like to do it, you do that. All right. You want to use the FOIL method, you do that. All right. If you want to use the vertical method, you do that. Whichever one appeals to you and will get you the right answer. All right. No pressure. All right. But I'm just showing y'all all the possibilities. All right. Y'all feel like y'all got this, or y'all need to see another one? Huh? Move on. You good? In the end, yeah. Just combine like terms. So I don't care how you multiply the polynomials, your choice, distributive property, vertical method, FOIL, whatever, you know, just give me the right answer. All right. I'm just showing y'all different ways of doing it. All right. So but you feel good, Alex, though? Okay. Let's move on then real quick, right? Little recap. So we have now used 3 methods for multiplying binomials. Be sure to practice each method and try to decide which one you prefer. All right. The methods are listed here. Let me give y'all the list real quick. Y'all know my handwriting not pretty, so I'm over here trying to give it to y'all nice. All right. There goes the list right there, right? Multiplying 2 binomials. Your choice, no pressure. All right. You can use the distributive property. You can use the FOIL method, or you can use the vertical method. All right. Go ahead. So all these 3 are for binomials, but for any polynomial, it's the vertical method or the distributive property. Okay. Same thing, vertical method or distributive property, right? For binomials, yeah. If it was me, I would put my money on either the distributive property or the vertical method because that works for anything, right? FOIL is a very special case that only works for a binomial times a binomial. All right. Mhm. That being said, let's make this harder. So we're going to be multiplying a polynomial by a polynomial, right? This the end game. This is what we want to do. So we have multiplied monomials by monomials, monomials by polynomials, and binomials by binomials. Now we're ready to multiply a polynomial by a polynomial. Remember, FOIL will not work in this case, all right? But we can use either the distributive property or the vertical method. Your choice, no pressure, all right? Now, this is going to be a funny looking question right here. This is a funny looking question. This question is asking you to multiply this using both methods. I'm going to do it using both methods, all right? On your test, I'm not telling you which method to use. Use whichever one you're most comfortable with and give me the right answer. I care about the right answer. I don't care about which method you use to get it. All right? Let's do both. All right? So I'm going to do A first. Crimson. So we got what? B plus 3 times 2b squared, or not to be squared, that's the question, minus 5b plus 8. All right? So tell me what to do. Distributive property, go. All right, so b plus 3 times 2b squared, good. So I have 2b squared times b plus 3. All right, next one. Right here. times b plus 3. Very good. All right, last one. Plus 8 times b plus 3. Perfect, perfect, perfect. Distribute to every term. First one is going to be what? 2. No, not 6. 2b cubed. All right. Next one is what? So plus 6. What? Plus b squared, right? Next. What's the next one? Negative 5b squared. Very good. What's the next one after that? Negative 15b. Next one. Plus 8b. Last one. Plus 24. Now I want to combine like terms, right? Combine like terms. What do I have? I have 2b cubed. What else? Plus b squared. Very good. What's next? Minus 7b. Very good. Plus 24. Excellent. That's my final answer. All right, let's do this problem again. All right. Just bear with me 1 second. I got b plus 3 times 2b squared minus 5b plus 8. All right. Now, I don't know about y'all, but when I do the vertical method for multiplying numbers, I always like to put the number with the most amount of digits first, and then I put the one with the smallest amount of digits last, right? And then I just go step by step through each one. I'm gonna do the same method here, right? So who has the most number of terms here? The 2b squared minus 5b plus 8. So I'm gonna do that first. 2b squared minus 5b plus 8, right? Then we're gonna do what? And again, I like the parentheses. They just make me feel good. Y'all don't have to use it if you don't want to. Times what? The b plus 3. Could you have switched them around? Yes, you could, right? But for me, when I was multiplying numbers back in the day, right? If I had 1, 2, 3 times 4, 5, right? This is how I would do it, right? The one with the most digits on top, and then the one with the less digits on the bottom, right? It's just a preference. All right. After that, what we gonna do? Go straight through it. 3 times 8, what's that? 24. Very good. All right. And then now 3 times negative 5b is what? So negative 15b. Let me put a plus sign here. Oh Lord. There we go. All right. 3 times 2b squared is what? All right. So I got a 6b squared. Imaginary 0, right? Now b times 8, what's that? All right, so plus 8b. Very good. Now b times negative 5b. What's that? Negative 5b squared, right? Now b times 2b squared. What's that? So 2b cubed, right? Then we're going to add these together straight up. 24 plus 0, what's that? 24, good, good, good. Negative 15b plus 8b, what's that? Negative 7b, very good, right? I keep forgetting to put that plus sign. 6b squared plus negative 5b squared is what? B squared, very good. And then 2b cubed. That's it, all right? Whatever method you want, I don't care. All right, give me the right answer. All right. Vertical method, distributive method, your choice. All right. Hmm?
If you do E times, if you plus.
Yes, you can do that. Yes. Yes, either way works. You can do that. Yes. That's the same idea as me switching, doing the b plus 3 on top and the 2b squared minus 5b plus 8 on the bottom. You know, so they are interchangeable, right? Long story short, 3 times 2 is the same thing as 2 times 3, right? Multiplication is commutative, so you can switch their order and get the same answer. All right. Questions on this? Good. All right, whatever method y'all want. No pressure. All right. Now that we got the generalities out of the way, the rest of what I have to show you is going to be a whole bunch of tricks. All right. And as the rabbit would say, tricks are for kids. All right. So the rest of what I'm going to say, if you want to take it to heart, cool. If you don't want to take it to heart, that's all right. Y'all have the methods that work for everything right now. So we have now seen 2 methods that we can use to multiply a polynomial by polynomial. After you practice each method, you'll probably find one that you prefer over the other, right? So let's look at the list of those methods real quick. It's the list that works for anything. Anything, your choice. All right. So to multiply a trinomial by a binomial, you use the distributive property, use the vertical method, whatever works for you. No pressure, no pressure. All right. Now let's talk about tricks. All right. We're about to get it. So multiplying special products. Mathematicians like to look for patterns that will make their work easier. Amen. A good example of this, right, is squaring binomials. Right. While you can always get the product by writing the binomial twice and multiplying them out, right? There is less work to do if you learn to use a pattern. Let's start by looking at 3 examples and look for a pattern. So let's say that I had x plus 9 squared, right? Yes, I could split that up. And that becomes what? X plus 9 times x plus 9. Do your method, vertical method, distribute, whatever you want, right? Boom. You're going to come out to x squared plus 18x plus 81. Same thing. Let's say I have y minus 7 squared, right? You can rewrite it twice. Y minus 7 times y minus 7. Do your method, whatever you want, vertical method, distributive method, whatever. Boom, boom, boom. Comes down, you get your y squared minus 14y plus 49. Same thing if you had 2x plus 3 squared. Copy it twice. 2x plus 3 times 2x plus 3. Use your method, vertical method, distributive method. I don't care. You'll come out to 4x squared plus 12x plus 9, right? So what about the number of terms, right? In each example, we squared a binomial and the result was a trinomial, right? So here we go, a plus b squared, but what does that equal? Something plus something plus something, right? So if y'all wondering, when I gave y'all that example, how in the heck did I do it in my head? This is how, all right? But it is a trick. You don't need to actually do it. Go ahead. No, that's it. Oh, okay. All right. So now look at the first term in each result. Where did it come from? The first term is the product of the first terms of each binomial. So since the binomials are identical, right, it is just the square of the first term. So a squared, right? So when I have a plus b squared, remember I'm rewriting as a plus b times a plus b. The first term is just going to be a squared. So to get the first term, right, of the product, square the first term. Where did the last term come from? The last term came from the b times b, right? B squared, right? So look at the example, you find a pattern. The last term is a product of the last terms, which is b squared, right? So that's how you get the last term. Finally, we look at the middle term, right? Notice that it came from adding the outer and the inner terms, right? Which are both the same, right? There's two of them, right? So that's why the middle term is going to be 2 times whatever the A and the B is. This is the pattern right here. Of course, if it was a minus sign, it would be negative 2AB. So here you go. So to get the middle term of the product, you multiply the terms and double their product. Putting it all together, this is what we have. This is what's called the binomial squares pattern. Again, take it to heart if you want to. Don't take it to heart if you want to. The methods that we spoke about before work for every single thing. This is just a trick that I'm showing y'all. All right. So if A and B are real numbers and you have A plus B squared, it's going to be equal to this pattern right here. A squared plus 2AB plus B squared, right? So in terms of the binomial, where does it come from? The first term is squared. That's the A squared. The middle term is going to be 2 times the product of A times B. And the last term is going to be what? Just the last term B, but squared. If it was a minus, A minus B squared, right? It's going to come out to this pattern, A squared minus 2AB plus B squared, right? How do we get that? The first term is going to be squared, A squared. The middle term is going to be 2 times the product of the two middle terms here, which is A times negative B, which gives us negative 2AB. The last term is going to be the last term squared. So negative B squared is just B squared. All right, this is how you get the binomial squares pattern. Again, you don't have to memorize it. What you have already works. I'm just showing y'all. To square a binomial, square the first term, square the last term, double their products. That's it in a nutshell. All right. Let's try it out. So if I had to do x plus 5 squared, which we know is what? We know that that's x plus 5 times x plus 5. Yes, you can use a distributive property. Yes, you can use the vertical method, right? But if you know the pattern, like I do, all right, x plus 5 squared, what is this? The answer is x squared, the first term squared, plus 2 times, what's the first term? X, times the second term, what's that? 5, plus, what's the last term? 5 squared. Put it all together, this is what? X squared plus 10x plus 25. And I'm done. That's the answer. All right? That's me avoiding having to do the FOIL and all of that. Questions on this? The other method, you know how to do that. You put them next to each other, distribute it. Or you put them vertical, you multiply straight up, and then you add them up. All right? Let's look at B. Oh, B is the one that makes me feel real happy, right? Because B is complicated. That's 2x minus 3y and then squared. What's the pattern? It's going to be what? 2x squared. Whoops. I didn't even see the minus sign there. Minus 2 times what's my A term? 2x times what's my B term? 3y. Right? Plus, what's my last term? Negative 3y squared. Good. All right. Put that all together. What does this become? 4x squared, right? Let me see. Negative 2 times 2 is going to be a negative 4. Negative 4 times 3. What's that? Negative 12xy, right? Plus, what's this? 9y squared. That's it. I'm done. Not bad, right? Again, just a trick that y'all can use. All right. Which two? That's the pattern. That's the pattern from up here. All right. Minus 2AB. The reason why is because when you do the FOIL method, for example, right, you're adding the two middle terms. That's where the two is coming from. They're identical. All right, so that's why we have -2 times A times B. All right,
That's like a formula.
that's a formula, right?
Like, oh,
Yeah. Again, you don't got to take this to heart. All right. Y'all can always do your distributive property, do your vertical method, and get the same answer out. All right. I'm just showing y'all a trick. That's all I'm doing. All right.
uh,
Nah, that's it. Those are the only two formulas. What I was doing before was explaining the formulas. All right. Feel like we kind of get this, so let's move on. Here's another trick. All right. So we just saw a pattern for squaring binomials that we can use to make multiplying some binomials easier. Similarly, there's a pattern for another product of binomials, but before we get to it, we need to introduce some vocabulary. A pair of binomials that each have the same first term and the same last term, but one is a sum and one is a difference is called a conjugate pair, right? So it looks like A minus B and A plus B. All right. So let me just define that real quick. Conjugate pair, right? So a conjugate pair is two binomials of the form A minus B and A plus B. The pair of binomials each have the same first term and the same last term, but one binomial is a sum and the other is a difference. Okay. Don't worry, none of them know about the food, so they're just leaving for the day. So there is a nice pattern for finding the product of conjugates. You could, of course, simply FOIL to get the product. By using the pattern, it makes your work easier. So let's look at the pattern for FOIL to multiply some conjugate pairs, right? We have x plus 9 times x minus 9. Same thing, distribute, combine like terms. This becomes what? X times x, x squared, x times -9, -9x, plus 9x times positive x is going to give you positive 9x, and then positive 9 times -9 is -81. Combining like terms, what do we get? X squared minus 81, right? X minus 8 times x plus 8. Do the same thing. Y times y squared, y times positive 8y. -8 times y is going to give you a -8y. -8 times positive 8 gives you a -24. Combining like terms, what do we get? Y squared minus 64. All right. What about the 2x minus 5 times 2x plus 5? Distribute that. 2x times 2x, 4x squared. 2x times positive 5 is positive 10x. -5 times 2x is going to give you a -10x. -5 times positive 5 is -25. Combining like terms, what do I get? I get a 4x squared minus 25. All right. What do you observe about these products? The product of two binomials is also a binomial, right? Most of the products resulting from FOIL have been trinomials. The first term is the product of the first term, right, of the binomials. And since they are identical, it is the square of the first term, all right? The last term came from multiplying, right, the last two terms, right, the square of the last term. So long story short, if I have conjugates, A plus B times A minus B, it becomes what? A squared minus B squared, period, right? Again, you don't have to memorize it. Y'all have the vertical method, y'all have the distribute method, it'll give you the same answer out. Yes, right? Well, no, difference of squares is the reverse. That's when I want to go from having the product to the factors. Instead, this is the reverse of that. I'm giving you the factors, and you're gonna give me back the product out. That's what that is. Yeah. Huh? Sure. Right here is good? Okay.
Why is that a problem? I, like, before this again, before this, the other trick,
Which one?
before this one.
This? The binomial squares pattern?
I found, before this
Which one is that? All the way back up here? The vertical method and the distributive property? That's the one that works for everything. Once you know them two, you can do everything. Everything else I'm showing you is a trick. It's all right if you don't get the trick. You don't got to know the trick. All right. Those two will work for everything. All right. All right. So check this out. All right. So why is there no middle term? Notice that the two terms you get from FOIL combine to zero in every case, the result of one addition and one subtraction. The product of conjugates is always the form a squared minus b squared, which is called the difference of squares, right? Which will lead us to this pattern. Let me show y'all. This is called the product of conjugate pairs, excuse me, pattern. So if a and b are real numbers, a minus b times a plus b becomes a squared minus b squared. Your conjugates are a minus b, a plus b, right? And your difference of squares is going to be the a squared minus b squared, right? The product is called the difference of squares. To multiply conjugates, square the first term, square the last term, write it as a difference of squares. Done. All right? For example, bam. So in this example, I have 2x plus 5 times 2x minus 5. Let's look at A, all right? Very simply, what is it? I'm going to use a pattern, all right? It's going to be the 2x squared minus the 5 squared. That's the answer. So 4x squared minus 25. That's how you use the pattern to get it, all right? Again, it's okay if you don't get it. You use what you know how to do. You have the vertical method, distribute method will work for this, all right? Let's look at B. All right. What's that going to be? It's going to be the 5m squared minus the 9n squared. Put that together. What's this going to become? 25m squared minus 81n squared. That's my answer. Done. That's how you use the pattern with it. Questions on it? Go ahead. That's only for conjugate pairs, right? Which means it's a binomial times a binomial where one is a plus and one is a minus. All right. If it's too much to digest, don't worry about it. Use a distributive property, use a vertical method. Give you the same answer. All right. Let's keep going. So we just developed special product patterns for binomial squares and for the product of conjugates. The products look similar, so it's important to recognize when it is appropriate to use each of these patterns and to notice how they differ. All right. So look at the two patterns together and notice the similarities and the differences. So let's compare them real quick. All right. Let's compare them real quick. So here you go. All right. So I have the binomial squares pattern a plus b squared, it's going to become what? A squared plus 2ab plus b squared. Or if it's a minus b squared, it becomes what? A squared minus 2ab plus b squared, right? This is for squaring a binomial. The product is going to be a trinomial, right? The inner and outer terms with FOIL are the same. The middle term is double the product of the two terms, right? For the product of conjugates, which is a minus b times a plus b, it becomes what? A squared minus b squared. You get this by multiplying conjugates. The product is a binomial. The inner and outer terms with FOIL are opposites, and there is no middle term. All right? These are the two patterns being compared to one another. All right, let's try this out. What's the answer for A?
Where?
All right, 2x squared. I'm listening. You're trying to do it in your head. All right, I'm just gonna follow the part. It does cancel out. Minus, right? 3 squared. So final answer, 4x squared minus 9. That's it. How did I know to do that? One of these was a minus, one of these was a plus. That's simple, right? Let's look at B. In B, they both, it's a repeat, right? 8x minus 5 times 8 times 8x minus 5, right? It's a repeat. So what's the answer going to be? Using the pattern. 8x squared?
-5.
Nope. Plus 2 times the 8x times the -5 plus the -5 squared. That's your pattern. Final answer, 64 x squared, right? Minus 80 x plus 25. All right? Simple. What about C? I have 6m plus 7 squared. We know that that's a repeat. 6m plus 7 times 6m plus 7. Use whatever method you want to figure it out. I'm using the pattern. This is going to be what? 6m squared plus what? 2 times 6m, right? Times the 7 plus the 7 squared. A little bit of math. What is this? 36 m squared plus, what's that going to be? Oh, Lord. What's 12 times 7? I don't even remember what that is. What's that, 83? I don't even know. Oh, Lord. How we going to do this? 21, 42, 84. Plus 49. All right. Last one, D. Y'all get the idea, right? Last one, D. I got 5x minus 6 times 6x plus 5. Go ahead. What's the answer? Y'all just seen me do 3 of them right here. It ain't that hard. What we gonna do? Good. What is it? Good. Plus negative 36x, right? Minus 30. What did we notice here though, right? These two binomials are not the same, right? They have a different A, different B term, so I can't use the pattern here. All right, so back to what you know how to do. Distributive property, or, right, you do your vertical method. Combine like terms, blah, blah, blah. Final answer, 30x squared. Oh shoot, what's that? 5 and 6, what's that? Negative 11 x minus 30. And then that's it. We good? All right, let's keep moving. All right, let's do a little blast from the past real quick. If it works. Really? Don't do me like that in front of everybody? Oh shoot, come on now. Oh Lord. All right, give me 1 second, y'all. Y'all can take a 2 second break. Hold on. All right, bear with me 1 second, y'all. 1 second. All right, sorry about that. Little technical difficulty on my end. All right. I want to start off with a little blast from the past. All right. So I want to add 3 over D plus X over D. How do I do that? What's the answer? 3 over d plus x over d equals 3x over d. So when I have the same denominator, I can add the numerators, right? Well, technically it's 3 plus x over d, but whatever. Y'all get the idea. 3x over d is 3 times that. All right, next. So I want to simplify 30xy cubed divided by 5xy. Do that for me real quick. What's the answer? Remember, numbers with numbers, variables with variables. Go ahead. What is that? 6, what? Nope. 6 what? No. X divided by X, what happens to that? Cancels out. Good, good. Y cubed divided by Y is? No. Y squared. That's my answer. All right. So you divide the numbers by the numbers, right? And then whenever you're dividing the variables, right? The exponents, what do we do with the powers? We subtract them. That's it. All right. All right, bear with me 1 second real quick, because this is just annoying me right now. 1 second. Yeah, this is doing this right now. All right, so here we want to combine like terms. Do that for me real quick. What's that going to be? 7? 11, a to the second. Keep going. Plus 7a plus 5. Good. Any questions on that? We're good? All right. So now we're going to be getting into dividing monomials, right? So we are now familiar with all properties of exponents, and use them to multiply polynomials. Next, we'll use these properties to divide monomials and polynomials. All right? Good stuff, good stuff. All right, so now we want to find the quotient of this. All right. So it's nothing different from what we just did before. All right. Numbers with numbers, variables with variables. All right. 54 divided by -6. What is that? Positive. It's 9. All right. -9. Now we're talking. Because a positive divided by a negative is a negative, right? So -9. A squared divided by A is A to the 1 power. B cubed divided by B to the 5th is B to the -2 power. Well, remember, it's illegal for me to have negative exponents, so this becomes what? -9A over B squared. That's my final answer. Nothing crazy there, right? Same old, same old. Do we need to see another example, or you feel like you got this? Move on? Huh? You want to see another example? All right. Oh, this is pissing me off. All right, try that out. All right. We good? All right. So -9 A to the what? Nope. Subtract division. All right. -5. And then B to the what? -1, right? And then it's illegal for me to have negative exponents. This becomes what? -9 over to the 5th B. All right, and that's it. Questions on this? Anybody? Good? Because I can't have negative exponents. So whenever I see a negative exponent, I put it into the denominator and make it positive. All right. Let's try another one. So once you become familiar with the process and you have practiced it step by step several times, you may be able to simplify a fraction in just one step. So check this out. Bam. All right. So you could just go straight down, step by step, right? Kind of separate these a little bit, right? 14 divided by 21, what's that? What's 14 divided by 21? Reduce it. Reduce it. What does that become? Something over something. 2 over 3. X to the 7 divided by x to the 11 becomes x to the negative 5? Negative 4. That sounds better. And then y becomes y to the 6th degree, right? And remember, negatives go in the denominator, positives stay up top. So final answer, all right? This is going to be 2y to the 6 over 3x to the 4th power. And that's it. Negatives go to the denominator and become positive. The positives stay up top in the numerator. That's it. Questions on this? So x is going to the bottom because that's a negative exponent power, right? It's negative 4. So negative 4 got to go in the denominator, become positive. The y is to the positive 6, so you just kind of put that in the numerator and you're good to go. Yeah, because it's positive. All right. All right, let's keep moving. Y'all need to see another example. Y'all feel like y'all get it. It's just simplifying a fraction. What you say? All right. All right, try this out. All right, let's knock this out. 28 divided by 49, what is that? What is it? 4 and 7, okay, good. And then x to the -4, and then y to the second, right? Negative exponents go in the denominator, positive exponents go on top. This is going to become what? 4y squared over 7x to the 4th power. All right. Questions on this? Good? All right, let's keep moving. So next we're gonna divide a polynomial by a monomial. Now that we know how to divide a monomial by a monomial, the next procedure is to divide a polynomial or two or more terms by a monomial. The method we'll use to divide a polynomial by a monomial is based on the properties of fraction addition. So we'll start with an example to review fraction addition. The sum of y over 5 plus 2 over 5 simplifies to y plus 2 over 5, right? Now we'll do it in reverse to split a single fraction to separate fractions. So, for example, y plus 2 over 5 can be written as y over 5 plus 2 over 5, right? This is the reverse of fraction addition, and it states that if a, b, and c are numbers where c does not equal 0, then a plus b over c is equal to a over c plus b over c. We will use this to divide polynomials by monomials, all right? Really nice little trick. So a little definition. The division of a polynomial by a monomial. To divide a polynomial by a monomial, divide each term of the polynomial by the monomial. That's the trick. All right. I'm gonna give you guys an example. So let's say I want to find a quotient of this. 18x cubed y minus 36xy squared divided by -3xy. First thing you do, rewrite this. It's going to become what? 18x cubed y minus 36xy squared divided by -3xy. So what you're going to do is you're going to put the denominator underneath each term in the numerator. So it's going to look something like this: 18x cubed y divided by -3xy plus -36xy squared divided by -3xy. All right, let me put that right here, right? After that, just do what you know how to do. 18 divided by -3 is what? What is it? -6, right? X cubed divided by x becomes x squared. Very good. And then the y's will cancel out, right? Help me out right here. A negative divided by a negative is a positive, and 36 divided by 3 is 12, right? And then the x's will cancel out. Y squared divided by y is just y, and that's my answer. I'm done. Questions on this? Anybody? We good? Remember, you always, when you're dividing exponents, you subtract the powers. 2 minus 1 is 1. So just y to the 1 power. Yeah. Y'all get it, or you feel like we need to see another one? Everybody? Everybody gets it? We good? All right. Doo, doo, doo. So next, I want to talk about dividing polynomials using long division. So you divide a polynomial by a binomial, right? We follow a procedure very similar to the long division of numbers. So let's look carefully at the steps we take when we divide a 3-digit number, 875, by a 2-digit number, 25, right? So right here, 25 is our divisor, right? Our dividend is going to be the 875, right? And our quotient is our answer that we're looking for, right? Remainder is what remains at the end. So 25 goes into 87 3 times, right? And 3 times 25 is 75. 87 minus 75 is 12, right? Then bring down the next number, which is 5. 25 goes into 125 5 times, right? So put the 5 up here. 5 times 25 is 125. Subtract that, we get 0. That's our remainder, all right? We check division by multiplication, or by multiplying the quotient by the divisor, right? If we did the division correctly, the product should equal the dividend. So 35 times 25 equals 875, right? So now we will divide a trinomial by a binomial, right? As you read through the example, notice how similar the steps are to the numerical example above. All right, so let's take a look. This is going to be fire. Bah, bah, bah. So here we go. So let's say I want to do x squared plus 9x plus 20 divided by x plus 5. This is how we're going to do it using long division. It's going to become what? X plus 5 over here. Well, hold on. Let me rewrite this first so you can see where this is coming from. First, we have x squared plus 9x plus 20 over x plus 5, right? Now I'm going to switch this into the long division. This is going to become x plus 5. And then we're going to have x squared plus 9x plus 20. Very simple. X goes into x squared how many times? I'm asking you, what is x squared divided by x? Once, right? X times, right? So this is going to be x up here. Now, x times x, right? X times x is what? X squared, right? Always put this in parentheses. X times 5 is what? So plus 5x. After that, you want to subtract. It's the same process. X squared minus x squared cancels out. 9x minus 5x is 4x, right? Bring down your next number, plus 20. Now, x goes into 4x how many times? Not 5. No. 4 times, right? So plus 4, right? Now, 4 times x is what? 4x. And then 4 times 5 is what? Plus 20, right? Put this in parentheses. We're going to subtract this now, all right? 4x minus 4x is 0. And that cancels out. 20 minus 20 is 0, all right? So what's my answer to this question? My answer is x plus 4. That's it. All right, so that's how you divide a polynomial by a polynomial. in a nutshell. Okay. Da, da, da. Let me just say one more thing. Ba, ba, ba. I just want like a big example that'll. All right, I noticed that the time is there. Just give me 1 second. Let me just get one example out with y'all, and then we'll call it at that. I'm just gonna do like a super example that sums up everything, and then y'all be good after that. Because you guys got the procedure down already. All right, so last example. Let's say that I have I have 8a cubed plus 27 divided by 2a plus 3, all right? I want to do this by long division. So this is going to become what? 8a cubed plus 27 divided by 2a plus 3. Before I could do this in long division, I have to expand the numerator a little bit. I have to account for the variables that are missing in the middle, right? So this I'm going to rewrite as what? 8a cubed plus 0a squared plus 0a plus 27 over the 2a plus 3. Now I could do my long division straight and it'll work. All right, let's try it out. So this is going to become what? 2a plus 3, all right? Put on our dividend now. This is going to be 8a cubed plus 0a squared plus 0a plus 27. All right? Do your long division. 2a goes into 8a cubed how many times? 4, keep going, 4a, no, 4a squared, right? 4a squared, right? Essentially, I'm asking you this. What is 8a cubed divided by 2a, right? 4a squared. That's what I'm asking you, all right? Let me erase that because I need that space. Huh? I added that, right? I have to expand it in order to get the right answer, right? Right, to get the right answer. Let's keep going. 4a squared times 2a is what? 8a, huh? 8a to the, no, 8a to the, a squared times a is a to the third power, right? Now 4a squared times 3 is plus 12a squared. Perfect. Now I'm going to subtract these. 8a cubed minus 8a cubed, that'll cancel out. 0a squared minus 12a squared is what? No, negative 12a squared, right? Bring down your next one. This is going to be plus 0a. All right, now 2a goes into negative 12a how many times? Negative 6a, right? Negative 6a. Now, negative 6a times 2a is what? Negative 12a squared. And negative 6a times 3 is what? Negative 18a, right? Put this in parentheses again, subtract. So negative 12a squared minus negative 12a squared, that's going to cancel out. 0a minus negative 18a is what? No. No. 0 minus negative 18a. What is that? What is it? 18a, right? Positive 18a, right? I'm asking you, what is 0 minus negative 18a? Negative is positive, right? So that's just 18a. That's what I'm asking you. All right. Anyway, bring down the next number. I got a plus 27 here. All right. Now 2a goes into 18a how many times? 9 times, right? So plus 9. Now 9 times 2a is what? 18a, right? And then 9, right? Times 3 is what? 27. Right? Put those in parentheses. Subtract this, right? 18a minus 18a, that's going to cancel out. 27 minus 27 is what? 0, right? So what's my final answer? 4a squared minus 6a plus 9. 4a squared minus 6a plus 9. That's it. Using my long division. So the lesson here, right? If you missing a variable, you expand it, right? Expand the dividend, right? By adding in a 0 next to that variable that's missing. Go ahead. Because I'm missing it. Look, I had 8a cubed plus 27. What happened to a squared? What happened to a? They weren't there. So I had to expand that and put in the 0a squared plus the 0a, right? Then now I had the complete dividend that I could do the long division with to get the answer out. All right? All right, so that's that. Stick around for a few minutes. If y'all have to leave immediately, just stick around for a few minutes. Let me just print out the practice questions and give to y'all. Right. If y'all gonna come back, be back at 1:15, let's say, be back at 1:15, and then we can do the practices together. Again, low hall, 4th floor, get your hot food if you want over there. You got snacks in 120 if you want. They got water, Chips Ahoy, and some yellow Lay's potato chip. All right. Huh?
Lay's chips.
There's no more Lay's chips. All right, no more Lay's chips. Sorry to tell y'all that. All right. I'll see y'all back at 1:15. If you have to leave, stick around for a few minutes. Just let me go print that and I'll bring it right back to you. All right. Those of you following online, have a good night. All right.